Let's discuss more examples about the first derivative test. So look at this example. Applying the first derivative test and find the relative extrema of fx equal to x squared minus 4 to the 2/3 power. Okay, so now what's the first step we have to do it? Yes, finding derivative of fx, right? So f prime x must be 2/3 x squared minus 4 to the 2/3 minus 1, so become negative 1/3, multiply inside 1, so become 2x. So if I simplify that, then f prime x, then this becomes 2 times 2 is 4, so 4x over now 3x squared minus 4 to the 1/3 power. Okay, so now from here we can find the critical value, just making both a numerator and denominator equal to 0. Okay, so 4x equal to 0, so that we got x equal to 0. Now x squared minus 4 equal to 0, because this power and the 3 doesn't do anything, so I just make it inside 1 equal to 0. Then you will get x equal to plus and minus 2. Okay, so we have total 3 different critical values, 0 and plus and minus 2. Okay, then let's create it, the interval table. So negative 2 here, and 0 here, and 2 here. So we have a total 4 different sections. Where? So as you see, these sections and this, and this basically. Okay, so you are choosing 4 different testing value. So one testing value must be smaller than 2, negative 2. One testing value between 0 and negative 2. One of them between 0 and 2. The last one bigger than 2. So it is up to you, okay? But I'm gonna choose the test number which I think easiest. So I'm gonna do negative 3, and negative 1, 1, and 3. Okay. Now we are looking for the relative extrema, which means we want to find out whether a tangent line slope is increasing or decreasing. Okay, so where should we input those testing value into f prime x or fx? Yes, definitely f prime x. Whatever is related to the slope, then prime function. Okay, so let's try input those values into the prime function. Okay, so I can utilize this one. So first of all, negative 3. So x equal negative 3, which means 4 times negative 3 over 3 times negative 3 squared minus 4. Okay, here, don't try to get actual value. The most important thing is you're finding the outcome slope become positive or negative. That's the key point here. So as long as you know the sign, either positive or negative, then that's it. Okay, so when I look at that, this become negative 12, and I know this become 9 minus 4 to the 1/3 power, so this become positive, this is minus, so total become negative slope. Okay, so I'm gonna put negative here and minus 1. So x equal negative 1. Then 4 times negative 1 over 3 times negative 1 square minus 4, okay? The 1/3 power. Again, we don't care about their outcome. We only figure out their sign, okay? So this becomes negative 4 over, now inside 1 becomes 1 minus 4, which is negative. Negative 1/3 become negative, so negative here. So negative over negative become positive. So I'm gonna put positive here, okay? Now 1. So number 3, x equal to 1. Then 4 times 1 over 3 times 1 square minus 4, 1/3 power. So when you look at this become positive because 4 times 1 become positive, and then it's negative here, so it become negative. So I can say that's also negative. And number 4, x equals 3, then 4 times 3 over 3, 3 square minus 4, 1/3, then this is positive over positive, so equal to positive. Okay, now let's go back here. Okay, then now we can make negative, positive, negative, positive. So of course this will be our relative minimum. This become the relative maximum. This become also relative minimum. Okay, here the some most likely the relative minimum can be same coordinate, I mean the same y value, but actually most likely it can be different value too. But still it is a relative minimum, so don't forget that. So now our conclusion becomes we have the relative minimum at x equal to negative 2 and x equal to 2, and the relative maximum at x equal to 0 basically. Okay, so now we found out where the relative minimum and the maximum points are located, right? Then how to find the point? Yes, we plug those critical value into the original function. Why is the original function? Because we want to find out the original point coordinate. That's why we are inputting all the critical value into the original function. So original function was x squared minus 4 to the 2/3 power. So I'm going to just copy. So we are inputting negative 2, 2 and 0 into here. So f0 means 0 squared minus 4 to the 2/3 power. So I can say negative 4 to the 2/3. Okay, if you calculate that, you got around 2.52. Okay, now f negative 2, then negative 2 square minus 4 to the 2/3, which means 4 minus 4 to the 2/3 power, so becomes 0. And then f2, so 2 square minus 4 2/3 power, so this becomes, so 4 minus 4 2/3 also 0. Therefore our conclusion, the relative minimum at negative 2 comma 0 and 2 comma 0, the relative maximum at 0 and 2.52. Okay, that will be the answer for this problem.